Hey guys, it's Leah again, and today we're going to go over Precalculus section 3.2, linear models, building linear functions from data. Our first learning objective is to draw and interpret scatter diagrams. Yay, I love drawing. So the first thing we need in order to draw and interpret a scatter diagram is some data. So this data table represents the apparent temperature versus the relative humidity in a room whose actual temperature is 72 degrees Fahrenheit. So at 0 humidity, temperature feels 64. At 10%, it's 65. At 20%, it's 67. And so on and so forth. So what we're going to do is, and if you guys want to get out your graphing utilities and do this, you can do it either with an online graphing utility, or you can do it with your graphing calculator. We're going to draw a scatter diagram by hand at first, treating relative humidity as the independent variable. So relative humidity will be on the x-axis, and temperature is going to be on the y-axis. Then we're going to use a graphing utility to draw the scatter diagram, and then we are going to do the interpreting part. Describe what happens to the apparent temperature as the relative humidity increases. Alright, so to draw a scatter diagram by hand, we're going to go from count by tens on our x-axis, go from 0 to 100. And our y-axis, we're going to go ahead and start at 62 because it's a little below where we're hitting the line. And then graph each of our data points, 0 through 100. And then we're going to use a graphing utility to draw a scatter diagram. So we put those coordinates either in a graphing calculator where the x-coordinates are list 1 and the y-coordinates are list 2, and then you just press the plot button. And if you need help with these settings, please let me know. I can go over this together in class or send you a video on how to do scatter plots on your device. Alright, thirdly, let's describe what happens to the apparent temperature as the humidity increases. So we're going to describe, we're going to interpret this line. Boom. As the relative humidity increases, the apparent temperature also increases. Take a moment to pause this video and write these two graphs and explanation down. On to the next learning objective. We are going to distinguish between linear and nonlinear relations. A linear relation will generally, as your x value increases, so as your independent variable increases, your dependent variable or your y value will also increase. Or vice versa, as your x value increases, the y value will decrease. So this is where our slope is greater than 0. This is where our slope is less than 0. A nonlinear function will have some increase and some decrease, which in this case, this looks like a nice quadratic, and this looks like a cubic. These two are nonlinear. This one looks like an exponential function. It doesn't have a nice steady increase, so it is also non-linear. Make sure you put all these examples in your notes. Alright, so our example problems, we're going to distinguish between linear and nonlinear relations. I know it's not rocket science, totally easy, right? Determine whether the relationship between the two variables is linear or nonlinear. A, survey says linear. B, survey says nonlinear. This is fun, right guys? C is nonlinear. D, I don't know, does it have enough of a curve to make it nonlinear? Oh, it does. It curves. See how it has this nice, little curve shape there that makes it nonlinear. All right, so we are going to find a model for linearly related data. So given our humidity data, we're going to select 2 points and find an equation of the line containing the points. So that's harkening back to our finding the slope, finding the intercept, and putting together an equation. So the 2 points that we're going to pick are 10 and 65 and 70. They did not pick 70 and 73 here. So they actually picked 80 and 74. Okay, so we are going to pick 2 points, 10 and 65 and 80 and 74. So we subtract the x's, subtract the y's, which is our 74 minus 65, and subtract the x's, which is 80 minus 10. And when we do that, we get a slope of 9 over 70. If we use the point slope equation, y minus y1 equals slope times x minus x1, we have the slope. We're going to take one of our coordinates. Y1 is going to be 65, x1 is going to be 10, and we're going to insert those 3 things into our equation. We're going to distribute and add 65 to both sides. So when you simplify this equation, you get y equals 9 over 70x plus 446 over 7. So here is our model for linear related data. And it creates that line, and truly at the end of the day, you want a line that is, if you got almost the same amount of points above or below the line at about the same distance. Third learning objective, use a graphing utility to find the line of best fit. Easy peasy. All you have to do is figure out how to input data into your graphing utility. So if we use the previous humidity temperature data, the line of best fit when we use the linear regression, and you could do this on your TI 83 or 84 plus silver, platinum, diamond edition. The only cautionary thing I say about this is if your linear regression doesn't give you out a correlation coefficient or this R value, and a correlation coefficient tells you how closely your data matches the line, and the closer you are to 1 or -1, the better your data fits a line. So if this isn't, you've got to go turn your diagnostics on. So if you go to your catalog, so go second in catalog, which is 0, and scroll down to the D's, highlight and select diagnostics on, and hit enter, and then when you calculate the linear regression, it should give you out the correlation coefficient. If you want to use a computer instead of a graphing calculator, you can go to linear regression online calculator, and it'll give you several different great options in your search, and you just input your data and it'll give you out your linear regression, your line of best fit. Then we graph the line of best fit on the scatter diagram, and it looks similar to what we graphed previously. And we have to interpret this slope. So my slope is 0.12. So the slope is 0.1209, which means that apparent temperature rises 0.1209 for every 1% increase in relative humidity. And I believe this is degrees Fahrenheit. I find that important as somebody who loves the science to mention that it rises 0.1209 degrees Fahrenheit. Every 1% increase in relative humidity. Use the line of best fit to predict the apparent temperature when actual temperature is 72 degrees Fahrenheit and relative humidity is 45%. So we're going to go ahead and plug in 45 for our x value into our linear regression. So it's 0.1209 times 45 plus 64.409. And we get about 69.8 degrees Fahrenheit. And that's the end of our lesson for today. Thank you.